Hi, welcome back to Alien Space Talk. Or Space Education. My name is Andy from Space for All, and today we're going to go straight into the mysteries of Uranus. I know you weren't expecting that, were you? It's a great, fantastic planet that has a bizarre orientation and to its complex system of moons and rings. Whether you're joining for the quick 15-minute that is free, or you're going to subscribe for the full 30-minute, I hope you enjoy and learn lots about this enigmatic planet. So strap on to journey into the cold and the distant reaches of our solar system to discover the wonders of Uranus. Let's start with the basics. It's the seventh planet in our solar system from the Sun. It's a fascinating world, unlike any others in our solar system. Discovered by Sir William Herschel in 1781, Uranus was the first planet found by the aid of a telescope. Yes, we needed a telescope. We couldn't see it before then. We didn't know where it was or what it was. It's classified as an ice giant, along with its neighbour Neptune. We'll discover that in our next episode. Due to its composition of water, ammonia and methane gas ices mixed with hydrogen and helium. So there's a lot of different gases all mixed together there, including water. Wow. So this is cool. But what makes Uranus truly unique is its extreme axial tilt. Unlike other planets which rotate more or less upright like we do, Uranus is tipped on its side with an axis tilt of 98 degrees, which means more or less it's rolling around the Sun on its side, leading to extreme seasonal variations. So it's going to have extreme weathers. It's rolling on its side, so it's not north and south, it's east and west, or it's north and south pole. Wow, that's really weird. And plus it's got moons and rings. How is this happening? This is really weird planet. This is going to be super cool. So let's see what we can discover about this, and hopefully I can give you an insight to this strange world. Uranus's unusual tilt is likely a result of a massive collision with an Earth-sized object early in its history. So well before, just as the solar system was being built, just after this 4 billion years ago, this started 4.6 billion years ago, this planet was hit by something about the size of Earth. Its collision not only knocked the planet over, the basic knocked on its side, but also influenced its magnetic field, which is significantly tilted compared to its rotational axis and offset from the planet's centre. So its magnetic field has changed as well. Everything about this planet is wrong. It shouldn't be like this. It got hit hard and it's completely bizarre. Because of its tilt, Uranus experiences seasons for at least, it's like, how can I put this in a nice term? We have 4 seasons that last about 3 months each. Autumn, winter, summer, spring, yeah? They last around 3 months, yeah? Uranus seasons, we estimate there's only 4. We hope there's only 4. They last 21 years. Imagine being in winter for 21 years. Imagine being in summer for 21 years. If you're in the UK, you know we don't like extreme hot and we don't like extreme cold. This is a bizarre one. This would be, would absolutely hate this. But it's fascinating. And the thing about it, because Uranus is rolling on its side, one of the hemispheres is facing the sun continuously while the other is plunged into darkness, which means it's tidal locked like the moon to Earth, Uranus is to the sun, which is really, really weird. It shouldn't be tidal locked like this. Not at all. It should be spinning so north and south get equal amount of light. It doesn't. It's locked to separate sides. One side's hot, one side's cold. One gets light, one gets dark. It's like that. When Voyager 2 flew by Uranus in 1986, this is Voyager 2, in 1986, it was summer on the planet's South Pole, which pointed directly at the sun. That's how long ago. That's one of the few times we've had a profile through it. The strange orientation also affected Uranus' magnetosphere, which wobbles significantly as the planet rotates. The magnetosphere is a unique configuration that leads to complex and variable interactions with solar winds, making Uranus's magnetic environment one of the most dynamic in the solar system, which means it's going to have really, really weird solar auroras. Have a look. This planet is truly magnificent, but really, really weird and really super cool. On one half, the atmosphere is a world of ice and wind. Because it's primarily composed of hydrogen and helium, but there's presence of methane that gives the planet the characteristics of a blue-greeny colour. Methane absorbs the red light from the sun and reflects blue and green wavelengths, resulting in Uranus' distinctive hue. So it's going to look different colours. So because the sunlight, the red light is absorbed, but the blue and green is reflected, we see it as a blue-greeny colour. That's why. If the red was reflected out, it looks slightly differently. Beneath its outer layers, Uranus' atmosphere is filled with complex weather patterns, just like Earth. The planet also has powerful winds. They're not as powerful as Saturn. These only reach 900 kilometers an hour, still more powerful than Earth. These winds are driven by internal heat, though Uranus emits much less heat than other planets like Jupiter and Saturn. Leaves the question about Voyager's 2 flyby also revealed faint clouds and bands, a large storm system, although they were less pronounced than those on the gas giants. Recent observation of Earth-based telescopes and the Hubble Space Telescope has shown that Uranus' atmosphere is more dynamic than previously thought, with seasonal changes and even occasional bright spots which might indicate storms. So it may not have the giant spot that Jupiter has, or it may not have the giant white spot. Uranus will have a blue-greeny spot, sometimes a different colour, a mixture of them, that could indicate another storm system, but we don't know. It might. Okay. The moons of Uranus are also really, really weird. Uranus is orbited by 27 known moons, each named after its characters from works of William Shakespeare and Alexander Pope. The 5 largest moons, Miranda, Ariel, Umbriel, Tatiana, and Oberon, are of particular interest as they show evidence of past geological activity. They're activity like the other moons of Saturn and Jupiter and Earth. Wow, these moons are super, super cool. Miranda, the smallest of the 5, has a surface that looks like it's been patched together from different pieces. It features enormous canyons some 20 kilometers deep, a mix of old cratered regions and young, less cratered areas. These features suggest Miranda may have undergone a series of intense geological activity due to tidal heating. Its own tidal heating on the moon, just like Saturn's moons. But not only that, if it's patched together with different pieces, that means these different pieces are shifting and changing all the time. If it's got cratered areas, that means it could have been impacted and these could have broken apart and been patched back together again. Who knows? But this is something that we need to discover. So we need to take a closer look at these. These are cool moons. Ariel and Tatiana also show signs of tectonic activity. They have activity as well, with deep valleys, ridges that hint to a history of stretching and cracking. Tatiana, the largest moon of Uranus, has a canyon system that rivals the size of the Grand Canyon, while Umbriel is the darkest of Uranus moons with a heavy crater surface that suggests it's been geologically inactive for billions of years. So you've got one moon here that has a Grand Canyon-sized gap in it, and so huge, and it's stretching and cracking. So this crack could get bigger, it could get smaller, we don't know. And then we've got another moon that is dark, and because we can barely see it, and we've only flown past it once, we know it's got craters on it. But geologically, those titanic plates could have been stuck together and no longer moving, or they could be moving. We just can't see it because it's dark. So there's a lot to learn about Umbriel. These moons with their varied and complex terrains provide a clue to the process that shaped not only the Uranian system, but also the border of evolution of the outer solar system. So not only are we looking at what happened to Uranus, but we're also looking at, hang on, this happened here and it's so far away. What happens in the Kuiper Belt, which is only a few more billion miles away? But there's a lot going on. And the rings of Uranus, they're just as fascinating. They're super cool. In addition to the moons, Uranus is surrounded by a system of rings. Unlike the bright rings of Saturn, Uranus rings are dark and narrow, composed mainly of large particles that likely remnants of a shattered moon or a captured object from the Kuiper Belt, because it is so close. So something could have broken up apart as it got closer. These rings were not discovered to 1977. That's a long time after the planet was discovered, when astronomers noticed that the star passing behind Uranus was occulted by something before and after the planet itself blocked out the light. Voyager 2 later confirmed the existence of 11 rings, and more have been discovered since then, bringing the total now to 13 rings. So these rings, even though we didn't know about them, we looked at it and we thought, hang on, why can we see this planet going all fuzzy and dizzy and then it's disappeared and then all fuzzy and dizzy and it's back? That's how we know, because something changed. And because of our knowledge of Saturn, Jupiter, we can recognise these sort of things. And then when obviously Voyager 2 flew past, ping, yes, there's the answer. These rings are confined to narrow bounds by gravitational influence and by influence of nearby moons, known as the Shepherd's moons. These moons, small moons, help maintain the structure of the rings, preventing them from spreading out into outer space. The origins of Uranus rings still remain a mystery, but are likely formed from debris left over from a moon that was destroyed by collision or tidal forces. We think it was created by that. However, it could have been created by an asteroid that hit or been ripped apart from the Kuiper Belt. There's a couple of possibilities there. We're not 100% sure. Only by studying it will we find out. Now, what do we know about the inner workings of the planet? The interior of Uranus is really, really weird. One of the biggest mysteries about Uranus is its internal structure. Unlike Jupiter and Saturn, Uranus doesn't radiate much heat from its interior, which has led scientists to speculate about its composition and thermal history. The planet's internal structure is thought to consist of a rocky core, not a liquid core, a rocky core, surrounded by a mantle of water, ammonia, and methane ice, with the outer envelope of hydrogen and helium. So we have a liquid core. Jupiter, Saturn have a liquid core. This has a rocky core, which is why it may be a gas giant. It's an ice giant because it doesn't have the same things. This is what we believe. This is what we speculate. We're only going to discover this by doing more study. A lack of significant internal heat suggests Uranus may have experienced a different formation in the history than other giant planets. Some theories suggest that the planet's internal heat was lost in its early history, possibly due to an impact that caused the extreme tilt, which could have released much of its primordial heat into space. Well, that's common sense. But was that the cause of it? Yes or no? We don't know, because we don't know what happened back then. We don't know what it's like before, so we don't know what this is a result of something, or this is how it's meant to be. We don't know. Understanding Uranus's interior is crucial for unraveling the history of the outer solar system and the formation of ice giants in general. Future missions to Uranus could provide valuable insight to these unanswered questions. We have to go back there. I'm sorry, but I want to see it. I want to know what's inside. And also, Uranus. Sorry, some of you may pronounce it differently. A lot of methane there. Might be a bit smelly, but let's find out. Uranus remains one of the most mysterious and least explored planets in our solar system. Its unique tilt, dynamic atmosphere, and intriguing moons and rings often a glimpse into the complexities of planetary science. As we continue to explore the outer reaches of the solar system, Uranus stands as a reminder of how much there is still to learn of the worlds beyond our own. If we don't keep studying, we still have a lot to learn. I keep saying it in every video, we have lots to learn. We're like babies at the minute trying to figure things out. We know a little bit, but we don't know everything. And this is a perfect example of this is a planet in our own solar system that is not acting like not a normal planet. It's on its side. It's tidal locked to the sun. So it's one side's always hot, one side's always dark. What's going on? Why is it on its side? We don't know, and we need to figure this out. You need to study and help us because we can do so much. But maybe what we're missing is a bit of imagination, a bit of common sense, a bit of thinking outside the box that we haven't thought of, come up with new ideas, new ways that we can discover the history and learn what happened. I hope this has inspired you to look more into the outer planets as well. Thank you for joining me in this journey. Don't forget, please like and subscribe. And if you want to subscribe for a longer version of this, please join. Happy to share these with you. Email me any questions, use the comments below, get in touch, check out spaceforalleducation.com. Lots of information on there. I'm going to keep making these. I really hope you're enjoying them and thank you for listening. Take care.